Hello and welcome to Control Delete Tutorials. My name is Jason and we are going to continue our C# basics. This time, in the last video we had talked about transform, translate, and rotate. Before that we had talked about a simple adding program. We've done if statements and logic and variables and methods. So I thought today what we could do is talk about another component. So we had talked about the transform component and being able to move our object and rotate our object. Now, currently, we haven't really talked about our box collider. We also haven't talked about adding a rigid body component, which is another component. Currently, when we play, if I move by pressing forward and back, down for back, and left and right keys, or A and D keys, the object doesn't fall, it just kind of floats in space. Now, a rigid body would help us to fall. It also allows us to add other forces. So, right now our cube is not really at a great view here, and also if we started falling, so if we add our rigid body, we're going to fall off where we're able to see. So to add this, we can just click Add Component. If I type RIG, we'll see rigid body comes up. Now, rigid body 2D is for 2D objects for making two-dimensional games. So we want to stick with just the rigid body. And if I pull up our magnifier here, just to help you guys see this a little better. So right here, this is our rigid body component. So if I have objects that have different mass, our higher the mass of that object will push objects that have a lower mass. Drag and angular drag have to do with how our object reacts to air resistance. So drag would be our movement through air resistance, and angular drag has to do with our rotation or torque through air resistance. Use gravity is exactly what it sounds like. When we use gravity, this is checked. When we don't want to use gravity, this is not checked. Is kinematic will turn off the physics for this object, so it won't fall anymore, even if use gravity is on. But it's more for things that are physics related, but things that are animated. So if I had an animated object, is kinematic is good for that. You're typically not going to have to touch these two controls, so we're going to skip over those and go down to constraints. And we have our freeze position. This will lock our position with regards to physics. Now, I can still use translate to move me, but I can't use physics to push my object. Freeze rotation causes our object to not rotate based on physics. So for now, I'm actually going to freeze my cube's rotation, so that way I don't tip over while my character is moving. Okay, and those are mainly what rigid body are going to have available to us. Now that we have the rigid body here, we can do a couple of things, but you'll notice if I hit play, my object will start falling. Okay, we don't want to do that. So let's move our object back up here. So we'll set it back up to 0, and we'll create a 3D object plane, and this will allow our object to move there. And our object is currently at 0, 0, 0, and it's 1 unit by 1 unit by 1 unit. So right now the plane is directly in the center of our object, which means that we'll fall through it. So we don't want to do that. So we're going to move our plane down a little bit. I'm just going to move it down by -0.5. Also, I want to apply some different colors here. Now, I'll have a tutorial that goes further into materials, so these will just be some basic materials just for now. So I'm just going to create a new folder called Materials. Like I said, I'll spend more time talking about materials in another video where I just talk materials. And we'll right-click Create Material. I'm going to call this Gray. And make sure you're in the scene view for that. You can't apply anything here in the game view. Okay. And you'll notice I didn't change the color. That's because we haven't actually made a grade yet. So here next to albedo is where we control our Rgb color and transparency if our object is allowed to be transparent. We're just going to select the color swatch here, And I'm going to just pick kind of a dark gray. And that's already applied. I'll make another one for my player box, my little cube here. So we'll go back to material. I'm just going to call this player. And I'll click and drag that onto my player. And I'm just going to go with kind of a blue. Alright. I'm also going to adjust my camera so that my camera is a little more favorable to this cube. So I'm just going to end up move it closer. So right now it's pretty far back in the Z, so I'm going to go with something like -3. Actually, it might be too close. Let's go -4. And I'm going to move it up a little higher. And I'm going to rotate it down in the X direction. Click and drag there. So let's do like 15 degrees. Alright, you know what? I think I do actually like -5. Maybe we'll just do 10 here. Alright, so those are the settings I'm going to use. So 0 to -5 and 10 for rotation for my camera. I'm also, for the time being, just going to position or parent my camera to the cube. So let's rename this cube while we're at it. Let's call this player. Okay, so we'll rename it player. Alright, so I'm going to take the camera and I'm going to parent it to the player. So I'm just going to click and drag it to where it highlights over the player. And I'll release it and we'll see that it indents in. And so what this is we have a parent object and child object. The child object follows the parent object. So if I move and rotate now, the camera is going to follow behind. And it's going to be a very one-to-one sort of movement, so it's not going to look great. But well, I also want to give myself a little bit of room here to move around, so I'm just going to set this to 10 by 10. So that'll give us a little bit of space. You know what? It's pretty big. Let's go 5, 5. That's a little better. Because I do want to show that I can fall off the edge. So now in my game view, I should see this. I'm going to change this to a 16:9 aspect ratio just because when we go to export this on most monitors we use, this is going to be the size. And I'm going to go ahead and hit play. And now I'll be able to see that if I move and rotate, the camera's going to follow behind. And since I have a box collider, I can go all the way out here to the very edge and still hold on. Now, if I were to take my player and turn off this rigid body for rotation, I immediately fall off and I start rolling. I don't want that to happen, so we're going to leave that there. But if I move out here, I will fall off. So that's the first thing, but we want to have the rigid body applied so we can maybe do something like make our object jump when we press the space bar. So that's what we're going to focus on. Alright, so in order to make our object jump, I'm going to create a new script. Now, typically you don't want to have a bunch of these scripts on the player that just do one thing. It would be a little bit better to organize them all into one script that work together, so that way we don't have to have them, the scripts communicate with one another. But I'm trying to teach you guys programming and show you how to make these things kind of communicate together and how different scripts can kind of work. So I'm doing them all in individual scripts. So we have one called move and rotate. The only thing it does is it focuses on moving and rotating. So the next one is going to focus on making our object jump. So I'm going to right click, create a new C# script, and we're going to call this jump setup, something like that. And we'll let the code compile. We'll select our player. Once it finishes there, again, we always want to check that this is public class jump setup and has the same name. So we'll select player. We'll move our jump setup underneath add component. It's going to add that in. And I like to have mine in order here. Actually, I typically want to have my rigid body up here. It makes no difference. This is just something silly about me. I like all my components up top and then my scripts down below. So I'm just going to organize it like that. So we'll go to our jump setup script. Okay, so let's start with creating our variables, and let's gain access to our rigid body component. Oops. There we go. All right, we'll give ourselves a little bit of space. All right, so I want to get access to the rigid body component. The way I do that is I call in the rigid body class. So we could do this one of two ways. We could either do a public rigid body class, and we could drag it in from the inspector. But what I'm going to do is, I don't want to have to always drag it in because I might forget to do that. So we're going to make this private. We can either do that by typing private, or we can leave private out and it should default to private. I'm going to type rigid body. In my last couple of videos, we weren't seeing the IntelliSense pop up here. I did end up fixing that. So now we do see this IntelliSense, and as we start typing, we'll see that it's going to select what it thinks I'm going to type. It gives me a little bit of information about it. So it says here, control an object's position through physics simulation. So that's what the rigid body is there for. And so as I'm typing rigid body, instead of typing it all out, once it's selected, I can just hit enter, and it'll do that. I'm going to just call this component, give it an identifier of RB, and then we're going to initialize this. We can do it in start. Typically, we want to do initialization in awake, but we can do it right here. So we'll do it in start, and we'll say RB. And so initialize just means to set the value of that variable. And we're going to set RB, and what we're going to do is we're going to get a component off of this object. So we're going to say get component. We use the less than sign. This is for us to denote a type that it wants us to use. The type we want to get, or the component we want to get, is rigid body. And since we're using get component is a method. So with like any other method, we have to use the left and right parentheses. So we're going to get the rigid body component. Something else we can do is we can require a rigid body component when the script is applied. Now we already have one, but if we want to do that requirement, we can do a square bracket, and we can say require component, and then we're going to have the type that we want. So it's going to be type of rigid body. Oh, this is oh, that's my mistake. Sorry, guys. We're going to cut this. So Control X. We want to be before the class where we do this. So this is where the require component goes, not inside of our class. Okay, so that'll go up there. So any components that we want to make sure are applied, we can type them up here before our classes, where our class is set up. So require component type of rigid body. So sorry about that, my mistake. We'll just cut and paste that up here and get rid of that space up there. All right, so rigid body RB. RB is equaling get component, our rigid body. And we can do this for any component. So if I want to get my transform component, I could create a private variable, private transform. You don't have to do this part, I'm just showing you how it works. Transform, maybe I call this TR, I don't know. And then here in start, TR equals get component. This is kind of redundant to do it for transform because there's already access to the transform class, but just in case we wanted to manually do it for some reason. But we don't have to do that. Okay? So again, that's optional. So we have our rigid body. Now we're going to write a brand new method, and we want this method here to detect whether or not we're on the ground. Okay, so we're going to hit enter 2 times after void update, just to give us some space. And I'm going to create a public bool method called isGrounded. And I'm going to do capital I for is because we're dealing with a method and we use that Pascal naming convention. Grounded. And left curly bracket, enter. Now, is grounded is currently underlined? That's because we haven't used a return type. So what we're going to return is whether or not the physics is detecting that we are currently on top of a collider. So how do we do that? Well, first we call on the physics class, and we're going to call the Raycast method from that class. So there's Raycast, and when we type in the left parentheses, Unity's IntelliSense or Visual Studio's IntelliSense is telling us that our first part is a ray, but we can put in transform dot position. Okay, so that's where our ray is starting from. That's basically our center point. And then our second part is going to be our direction that we're firing the ray. So the ray is just this invisible line that shoots down and detects things. So we're going to use, like we learned in the previous video, our vector 3 shorthand for down. So the start position is where it's starting. It's pointing in the down direction. And finally, we want our length of that ray. Now, our object is 1 unit by 1 unit by 1 unit. So technically, we could go 0.5. But what I want to do is, I'm going to have this detect a little bit further down. Mostly because I sometimes am not great at calculating when I need to jump in the game. And so this gives me a 0.5 distance down where it's checking. So it's actually going to let me detect a little bit further down than when I'm actually on the ground. And we can always alter these numbers and stuff while we're doing this. So then what I'm going to do is, I'm going to say if we are on the ground. So if we're on the ground, or if Physics Raycast detects us on the ground or on top of another collider, it's going to be true. Otherwise, it's not going to be true. So then we can up and update. We can say if we are grounded. So before we had learned that we can just write in, we're going to say is grounded, and we're calling on the method down below, so we have to put in those left and right parentheses. But we're going to detect something else. So again, in a previous video, we learned that we can use and, the two ampersand signs for and. So we want to say if we are on the ground and we input the jump button. So we're going to do input dot. Now we have three options here for get button. We have get button down, and get button up. We have more options than that, but the three we're looking at. So get button is true the entire time the button is pressed, and then immediately false when we release it. So we don't want to use that because then it's going to return true multiple times. Get button down is true for the frame that the button is pressed, and then immediately false. So it's only true for one frame. And then get button up is true on release of the button. So we're going to do get button down, and the button we want to use is already set up in Unity's input manager, and that's called jump, and that's set up to the space bar. Okay, so if we're grounded and we press jump, we're going to apply a velocity upward based off of a force. You can also use add force, so you may see this done two different ways. One way would be to call on our rigid body, apply a velocity, and our velocity would equal an upward direction. So that's going to be vector 3 dot up multiplied by a force. Now, I could type in and hard code a force here and hope that that one works out really well. And I've tested this before, and I like this one. Or we can create a variable that we can change easily. So let's do that. So we'll say public float jump height, and we'll set that to equal 10.0f. And then we can double click on where it says jump height and hit Control C. And then we'll highlight this 10.0F and replace that. So that way we can change this in Unity's inspector. Control-Shift-S. And now when we come back, let the code compile. We'll go to our player here. Once the code finishes, we'll see that we have our jump and our jump height set to 10. All right. Also, I want to make sure that I save my project. That's something we should do before testing at any point, because you never know when something's going to crash and you're going to lose your work. And we had changed where the camera is and added some colors and applied the colors. So make sure to save scene and save project. You don't really need to save the project settings, but it's a habit that I get into with everything. So always save scene and save project just while you're at it. All right, so we're going to hit play. And now we should see I can move around, and if I hit the space bar, I jump. If I hit the space bar while I'm in air, it won't jump again until it's detected that I'm on the ground. Okay, so that's how that works. So just to recap, we applied a rigid body. We've gone over some of the settings. We've shown how we can apply a force here. Now another thing, we're not applying a force, we're changing the velocity in this case. Another thing you might see is using Rigidbody.Add Force. And there's a couple of different versions of this. Add explosive force, add force, add force at position, add relative force. So if I was to do add force, this one's going to be a little different. So here we can see the force and the force mode. Now I don't want to use these together, but I can show you the difference for these. So if I do add force, this one's going to use, so we're calling on the add force method of the Rigidbody class. And so here, the first part is going to be our force. So we could try jump height. Okay, jump height. And we need to first have a vector 3. So we want to have our direction. Vector 3 dot up multiplied by our jump height. So it's very similar to what velocity is, but they actually work differently. And then we have force modes. You can see each one is a different setting here. Add a continuous acceleration to the body, ignoring its mass. Force. Add a continuous force to the rigid body, using its mass. Impulse. Add an instant force, impulse, to the rigid body, using its mass. And velocity change. Add an instant velocity change to the rigid body, ignoring its mass. So let's try out impulse. And I'm going to comment out this line of code. So now we're just doing add force. And the nice part about this is we have this variable, so if it doesn't work, we can change the settings and see at what point we get the desired jump that we want. So Control-Shift-S. Let's get out of play mode. You should always get out of play mode while you're changing your code. I should know better than that. Okay, so our jump height is 10, and our mass is currently 1. And that actually works pretty good as is. Now you could do different things where maybe you want to add a continuous force. So let's say we have this one for our jump. And let's take this off. So I'll cut that out. And let's say we want to make it so if we press jump at any time, so if let's do input dot get button, and so this is going to be a continuous, and we'll do I'm going to do fire 1, which is set up for a left click, just to test this out. So if we press, so this doesn't take into consideration whether we're on the ground or not. So this would be more like a jetpack kind of setup. Okay, and I'm going to change from force mode impulse, because that one's going to be a so we'll try force first, just to see how this works. And so it's going to add this to it as long as we're pressing the button. So what I want to try to do is just give it enough force that it doesn't take off flying. Okay, so this would be better for like a jetpack. So we'll Control Shift S, save. And so we should still have our jump. And we want the jump to be the main control. So this could be something we unlock later on in our game. Okay, so we can move. I press space, that still works. Okay, so I am holding down my left click, which should be set up to fire 1. And if we take a look at our project settings, input, now we go down to fire 1. That is a left control mouse button 0. So mouse is 0. That's a left click. Okay. So it didn't give me enough force to take off like I had hoped. Okay, so let's see. Input get button, fire 1. Okay, everything's spelled right. So that might not have been enough. Let's put a new variable, because I don't want to mess up our jump. So we'll just call this jetpack. Let's just say jet force. And we'll set it to something a bit higher here. So let's say 100. Go big or go home. We're going to multiply this by our jetpack. So add force, vector 3 up, multiplied by jet force with our force. We'll save that. Now we may end up taking off here, or we may end up doing nothing, and maybe I'm missing something, but we'll see. So we have our jet force and we have our jump force. So let's make sure everything works. Okay, so I can move around, I can jump, and if I left click, oh, there we go. Oh, that really took off a lot. Okay, so let's lower this down. Go drastic, we'll go 20. I want to make something that just allows me to kind of hover as I click. Okay, there we go. So that's pretty weak. You know, I gotta click a lot just to have that control. So let's see, let's try 30. And that's the nice thing about having these variables here. Alright, oh yeah, that's a lot better. Okay, so 30 works pretty good. So as I get close to the ground, I can kind of left click to kind of hover myself. Yeah, that works really good. Alright, so 30 is a good number. So here's what we do. We go back to the script, and we'll put 30 as our new default. That way we know that's a good amount to use. And we'll save that out. And that'll kind of wrap up this video. So we've seen how we can use AddForce and Rigidbody Velocity. Now you can also use Rigidbody Velocity for movement, very much like we did in the other video showing move and rotate. The problem being with that is adding this velocity change causes you to fall slow based off of your velocity, because you're constantly updating this number, and your Y is set to 0 when you're moving with this. So when you're using vector 3 forward, it will set your vector 3.y to 0, which makes you fall slow, and that doesn't work very well for that. And there's ways around that, but I mostly just want you to see how we can set up our jump, how we can call components, how we can create a method that checks whether we're on the ground, and create some if statements that say if we're on the ground and we jump, what happens, and how add force is used. So hopefully you like this video. If you did, give me a thumbs up, and I'll see you in the next video. Thanks for watching.